Welcome to our quick guide on artificial intelligence. Today, we'll demystify some core concepts and terminologies in AI, from narrow AI to artificial superintelligence. Whether you're new to AI or looking to brush up on your knowledge, this guide will help you to understand the critical distinctions in this fascinating field. Artificial intelligence, or AI, involves systems or machines that mimic human intelligence to perform tasks and can iteratively improve themselves based on the information that they collect. Let's start with narrow AI. These AI systems are designed to handle specific tasks. Examples include voice recognition systems like Siri and image recognition tools used in medical diagnostics, as well as more capable systems like ChatGPT. Narrow AI is highly specialized and does not possess broader contextual understanding beyond its specific functions. Importantly, narrow AI encompasses all of the current AI technology. General AI, or AGI, AMI, and ASI are all theoretical technologies. Next, we have general AI, or AGI. This represents a theoretical milestone where machines can perform any intellectual task a human can. AGI would not only mimic, but truly understand the reason across a broad range of activities, far surpassing today's AI capabilities. Although theoretical, leading developers and thinkers in the field of AI do not believe that there are any technological limitations to accomplishing AGI, and many believe we are a mere few years away from achieving this goal, with most anticipating AGI by 2030. Leading concerns with the general AI are massive white-collar workforce realignment and a broad topic called alignment and superalignment, which looks at developing AI that is aligned with human interests. AMI, or Advanced Machine Intelligence, as termed by Jan LeCun, refers to a future theoretical form of AI achieved through energy-based models. AMI aims to reach the capabilities of AGI by modeling the complexities of intelligence through sophisticated, energy-efficient computational models. It is believed that this model will be capable of multisensorial input with integrated abstractions and with the capability for titrating specific levels of intelligence. Beyond AGI, there is artificial superintelligence, or ASI. This form of AI could exceed all human intelligence, enhancing reasoning, problem-solving, and potentially emotional understanding. The potential of ASI extends vast opportunities and poses significant ethical considerations. This technology is beyond the scope of our talk, but if you're interested in learning more, I'd recommend the seminal work Superintelligence by Nick Bostrom. Large language models, or LLMs, are advanced AI systems developed to understand and generate human language. These models utilize transformer architectures, a type of technology that processes words in relation not just to one another sequentially, but across entire texts, which enhances their understanding of language context. LLMs are trained on extensive datasets comprising diverse types of text from books, articles, and web pages. This training equips them to perform a wide range of language-based tasks such as translating languages, summarizing documents, and even interpreting linked textual and visual information for tasks like image-based search. Beyond these capabilities, LLMs are also foundational in powering applications like chatbots, writing assistants, and customer service automation. However, their ability to mimic human-like text raises important ethical considerations. These include the risk of perpetuating biases present through their training data, generating convincing but potentially false information, i.e. hallucinations, and concerns about user privacy. As these models become more integral to our digital experiences, addressing these ethical challenges is crucial. Please watch the following compilation of opinions from radiologists and clinical social media influencers compared to opinions from AI software developers and philosophers in the fields of computer science and neuroscience.
So in conclusion, I definitely want AI to be incorporated in radiology because I feel like it'll help us quite a bit. And I'm not scared about being replaced by AI because I just don't see that happening anytime soon. Maybe not.
So, no, I'm really not worried about a robot taking my job. There is so much that goes on in radiology that I don't think that any robot could really perform all of the tasks of a radiologist.
And AI replaced doctors. I think we need to distinguish one very important thing. AI is not replacing people. AI is replacing tasks. The analogy that I always give to medical students is that autopilot flies plane, right? If you hop on a commercial plane, go elsewhere, an autopilot system, which is a computer system, flies the plane most of the journey. And we accept that, and we're pretty okay with that. But you still see pilots there. You still have the pilot, the co-pilot, they sit at the cockpit, they're there all the time, but they do not actively fly the plane most of the time.
We need to have a strategy with AI. And an investment in a strong AI program that we are doing in the department so that we can improve our workflow, we can have a better, more effective triage system, we have a better diagnostic tools, we can communicate more effectively and efficiently, and also we can have an impact on the research in this space by looking at health outcomes and cost.
My belief is that all repetitive human work that doesn't require the deep emotional connection between two people, that will all be done in the next couple of decades, better, cheaper, faster by AI. And that is somehow left out of the conversation. It's always about factory robots and self-driving cars. But what they don't talk about is all of the white-collar work.
Let me start by just saying a few things that seem obvious. I think if you work as a radiologist, you're like the coyote that's already over the edge of the cliff, but hasn't yet looked down, so doesn't realize there's no ground underneath him. People should stop training radiologists now. It's just completely obvious that within 5 years, deep learning is going to do better than radiologists, because it's going to be able to get a lot more experience. It might be 10 years, but we've got plenty of radiologists already.
In about 2015, I famously said it didn't make sense to be teaching radiologists to recognize things in images, because within the next 5 years, computers will be better at it.
Yeah. Are we all about to be radiologists, though?
Well, then computers are not better at it. I was wrong. It's going to take 10 years, not 5.
Okay.
I wasn't wrong in spirit. I just got it out by a factor of 2. Computers are now comparable with radiologists at a lot of medical images.
Yeah.
They're not way better at all of them yet.
But they'll only get better.
Yeah.
You know, and being a radiologist and being like those things, it's easy to see how AI just cancels those professions, or at least makes one person, you know, so effective at using AI tools that, you know, one person can do the work of 100 people, so that you got 99 people who don't have to be doing that job.
So what does AI think about its role in the future of radiology? Take a look at this cartoon generated by DALL-E in 2023 with the prompt, create an image that shows a radiologist's workflow after the advent of AGI in the style of a New Yorker cartoon. Thank you for watching this video presentation on AI and radiology. Please continue to complete the few remaining questions in the survey.